Can you guys hear me?
Yeah.
All right, well, welcome to September's meetup. Very happy to have our speaker, Lucas. So a little bit of story, right? We did have to make a change, and Lucas was very grateful, or very willing to help us. And I think it's going to be a really awesome talk. Just to tell you, like, basically what I did is I went to LinkedIn and I was like, is there anybody in Maryland doing interesting things with sport analytics? And Lucas came up, and then we had a conversation. So I think it's going to be a really interesting talk. I love these kind of presentations. I think the folks that have passion projects are always a little more enthusiastic about what they're working on, and always are more willing to share. So we have a smaller turnout. I would say definitely feel free to ask questions. Lucas did ask that you do it at the end, but if you have anything that you would like to ask him, please ask away. So just a quick intro. I did just change the slide. So it used to be Variant Technologies. So Silver Edge is a defense contractor. They've been supporting us for a couple of years. If you're interested in learning more about what they're doing, please reach out. I know they've recently expanded. They've added a couple of new companies. Clear Edge is another defense contractor that we work closely with. They helped us with the conference, and they've been, a partner for very long. So if you're interested in learning more about them, please reach out. Aries is my company. All you gotta do is come up to me and talk to me, and I'll tell you everything you want to know. Scuttlebutt's a little different. This is actually not a defense contractor, surprisingly, but they help staffing for defense contractors. So just one step removed. They're trying to change the way that hiring is done and finding candidates. If you're looking for an opportunity, I would definitely say reach out. I can put you in touch with the person that found it. He's a really great resource. Even if you ended up not using the service, I would highly suggest talking to him. He knows everybody in the industry. So I am working on the next couple of events. We're trying to iron out what we're going to do in October and November. But December, we have a speaker that's going to be talking about cybersecurity future threats. That'll probably be online. I'm kind of getting into this pattern where we're going between online and virtual, or online and in person. That one will probably be online because of the holidays. It just makes it a little easier. And then starting off the year, we have 2 or 3 speakers lined up for the first couple months. So we are coming back next year to do the conference again. I know some folks here did come to the conference. It was a great turnout. We had a lot of great speakers. We're going to be back at UMBC on June 10th. We're already doing the planning, getting the sponsors, getting the speakers. If you know anybody that would be good to speak, please let me know. If you know them personally, you can make the introduction. I would like that. But even if you just throw a bone, I'll chase it. So just give me any suggestions. I'm open. All right. With that, I'm going to do the intro. So Lucas Kelly is a writer for the baseball analytics website FanGraphs and a data scientist at the World Wildlife Fund. He's a baseball analytic hobbyist and loves to play and write about fantasy baseball. I'll stop there and let him do a lot more of the introduction. I did look at the website, so if you're interested, if you go to the FanGraphs, you'll see a lot of interesting things. If you're into baseball, it's a great resource. So with that, at the very end, I will have giveaways. I love giving away swag, so just come up to me and maybe I have a book or a shirt that you can take away. With that, I'll hand it over to Lucas.
Thanks, man. All right, hello everybody. Welcome. Like he said, using a baseball terminology, I was brought in off the bench for this talk. So my presentation is going to be replacement level. Okay, so just get that warning out of the way from the start. So I'm going to talk to you today about, like was said earlier, it's really just a passion project for me. This is a project that I started probably a few years ago, even though, let's see, I'm looking for the present button. Where is that thing on Google?
Right, F5.
F5?
Where's the slideshow on the top?
Top right next to the share.
Top right.
Oh, never mind.
Yes, thank you. Got it. Okay. This is a passion project. It's really something that I do with spare time, and spare time is harder and harder to find every single day, as I'm sure a lot of you know. Maybe not. Maybe you're on the other end of that and you have more time than you can handle. But it really is something that I've dedicated a significant amount of time to, though it really seems like it requires a lot more time than what I have. So you're going to see sort of like a hobbyist trying to do cool stuff with data science and baseball. So the title of this is Jolt Picks, and that's because that's the name of the model that I've created. I've created this model and I've called it Jolt. And Jolt was Joe DiMaggio's nickname, and I'll tell you a little bit more about him in a second. Who here knows about Joe DiMaggio, or at least has heard his name before? Okay. Is anybody here like a really big baseball fan? Okay, good. I'll be able to trick you and make you think I know what I'm talking about. So this is Joe DiMaggio. Joltin' Joe was his nickname, and he's famous for a lot of reasons. He dated Marilyn Monroe. I think he married Marilyn Monroe, actually. Not so bad. He was a Yankee center fielder. One of the greatest baseball players of all time, no doubt about it. One of the greatest. A legend. He's in the Hall of Fame. Anybody who really knows about baseball knows about Joe DiMaggio. But what he's really most, I would say, known for amongst baseball fans is this hit streak that he put together in a single season, that is. One single season, 1941, he hit 56 consecutive hits. So that means every day that he came to the plate for 56 straight days, he got a hit. So if he was in the lineup, he got a hit. That's incredibly rare. I can't even explain it how rare that is today. And so within that season, he hit 375, right? So he hit 375. That's one of the best baseball seasons anybody has ever put together. Ted Williams was similar to Joe DiMaggio, an incredible hitter. I'm sure you've heard of his name if you've heard of Joe DiMaggio. Ted Williams was one of the last players to ever hit 400. Okay, so just think about that. It works in the same way as percentages, right? So if you just take that 375, that means he's getting a hit 37.5% of the time he comes to the plate. That's not so great. If you really think of it in terms of how often are you successful, that's not very good, right? If you applied that 37%, if you round up 38% to anything else in life, you'd want to be doing that thing more successfully than 37% of the time, right? So it's pretty amazing. It goes to show you how difficult baseball is. And just to give you some context, 375 is the way he hit that season. This is the website that I write for. It's called FanGraphs. I get giddy every time they talk about FanGraphs on ESPN or Fox. It's a pretty well-known website, and I'm incredibly fortunate to be able to write there. In fact, sometimes I feel like I'm an imposter and I don't belong there. Some of the great writers that write for that site. But this is where you can find a lot of my work. However, there's a lot better writers on this website than me, so you can read about all kinds of cool analytical stuff. And if you're someone who doesn't really care about baseball all that much, but you do care about data, you're a data-driven person, a data scientist, maybe you're a student, maybe you're learning data science, there's an incredible amount of data on this website that you can get with the click of a button. You can download CSVs like crazy. I mean, I've been working for this site for 2 years. I've been a fan of the website for probably 5 or 6 years, and I'm still every day I'm finding new data to download off of this site. So it's a great place if you're just looking for some free data that you can work with. But I want to put this in context. The season is almost over in 2022, and I'm going to sort this sort of spreadsheet here by qualified hitters, which is this minimum PA, that's plate appearances. So, if we sorted this down to 10 plate appearances, right, and then we sorted this whole thing by batting average, we're going to get somebody who's batting 462. But this person is batting 462 on the year. They've had 16 plate appearances. They've only played 4 games. And they're doing pretty darn good, actually. This is James Outman. Let's take a look at him. Might have to add him to my fantasy roster here. He plays for the Dodgers. Not bad, but, what are you going to do? 4 games, 16 plate appearances, could be total luck. So if we change that to qualified hitters, and then we sort by batting average, we have 327 on the year. So that's pretty darn good. And that's Freddie Freeman of the Dodgers. He used to play for the Braves. We also have Jeff McNeil right behind him, plays for the Mets, 320. That's pretty good. There's The season ends 1 week from yesterday. The season ends on Wednesday. So no one is going to get to 357. No one's going to even get close to 357, which is what Joe DiMaggio did in less than a week, right?
75.
375, is that what it was?
Yeah.
Wow, okay. Jeez, even impressing myself. So, again, that's like way out of reach. It's not going to happen. And it's probably never going to happen, to be honest. The game has changed. It's completely different. It's probably just never going to happen again. Okay, so we've made this point. I've driven it home that this guy was really good. He hit 56 in a row, and that really leads me to the whole point of this talk. The whole thing that I'm trying to do with this model that I've built is play a game. And it's really fun, actually. It has a podcast. You can listen to the podcast every single day. They break down the hitters that are likely to get a hit. But here's how this game works. It's called Beat the Streak. Every single day, you are to pick one player. It could be any player. It could have been that guy Outman, who only has like however many plate appearances it was, right, in 4 games. It could be Freddie Freeman, who leads the league in average right now. It could be any player. Every single day, that player has to get a hit, but you can choose a different player every day. So if I made my pick today, I could have picked Freddie Freeman. If I make my pick tomorrow, I could pick Aaron Judge. If I make my pick the next day, I could pick this guy Outman. It doesn't matter. You can pick anybody. Every day, that player has to get a hit, and you have to do that 56 times. Okay, so if you get a hit, your streak continues. You can pick another player. They get a hit, your streak continues. If that player doesn't get a hit, you go back down to 0. There's also this fun thing called double downs. So let's say I've strung together like 7 hits, or real other people have strung together 7 hits. I've just chosen those players to get those 7 hits. That's the best part about this, is everybody else is doing all the actual hard work. If you double down, you can get 2 picks in that day. So if you pick 2 players and they both get a hit, then you jump up. If you were at 7, you would jump up to 9 in one day, right? But if either of them doesn't get a hit, you go back down to 0. So that's called a double down, and it's a little bit of a gamble. But it's a way to gain an advantage. So I've already talked. Well, actually, let me go back to this Beat the Streak, and I want to go to the website now. So a little bit more about Joe DiMaggio before we move on. I forgot to play this. Just watch this clip of him, just so you get a sense of that swing. Look at that swing. Not only was he's an incredible hitter. But boom, watch him go out of the box. As soon as he hits the ball, he's gone. Look at that. I mean, he's just running like crazy, right? So he was fast, he could hit. It wasn't just that he was an incredible hitter, it was that he put a lot of other skills together. And that is really probably one of the most important things about playing this game, is it's not just looking at batting average. If you're looking at just batting average, then you're doing it wrong, because you're only going to get it like 36% of the time for the best hitters, 32% of the time for the best hitter currently. So it's about putting together and trying to understand all of the skills that a baseball player has, not just how often are they getting a hit. Joe DiMaggio has that 56 hit record. This is Baseball Reference. Some stats about all of his season that he strung together in his career. Just a little bit more about Joe DiMaggio. This is when he was fought in a war. He was an incredible baseball player, and then he went away for 3 years and had to fight in a war, and then he came back. And when he came back, he hit 290. 290 is still incredible. Then he bumped it back up to 315, 320, 346. So this is just an incredible human being in so many different ways. And it would not be fair to mention that. So he hit 56 in 1941. Here are all the players who have had the most hits put together in a hit streak compared to him, and that's Willie Keeler. He played for the Baltimore Orioles before anybody could ever remember, and was it even real? Who knows? Pete Rose came after him, 44. Bill Dallin, I don't even know who that is, 42 games, 1894. So you can tell, all of these hit streaks happened a long time ago, and nobody is going to be doing it, nowadays, probably at all. So this is Beat the Streak. And you might think, what's the point? This seems like, okay, it might be fun. The prize is $5.6 million. So if you can do this, you get 5.6 million. Okay, I'm here right now telling you about this game. If I had won, you wouldn't see me. Okay, I wouldn't be here in this room right now. I'd be far, far away from the state of Maryland. Not that I don't like Maryland, but you know, if you got 5.6 mil, what are you still doing here? So that's like the whole point, right? And that's why so many people are playing. Okay, now let's look at the success of people that have played this game over time. You can view the leaderboard here. And I think the closest anybody has gotten, let's see, 37, that's an active streak. Okay, so an active streak right now stands at 37. That person is probably so mad because it doesn't continue into next year. They made it to 37, that's pretty good, but like, you know, they're obviously not gonna win because there's only 6 or 7 games left. All season in 2022, we've had 45. So could you imagine if you were this person and you had 45 and you're sitting on the couch watching your guy hit? I mean, that's stressful. Okay, but then all time, 51. So this person came the closest out of anybody. He still missed it by 5 hits. So $5.6 million is a lot, right? I'm not gonna go through the mathematics of all of this. I mean, it's pretty straightforward. You can follow this. I'll have it linked in my slides if they get shared. But somebody just decided to string together the probability of putting all of this together, and you can read this all you want. But this is the likelihood of actually winning the beat the streak game, right? So, and that's percent. That's not like a decimal that hasn't been turned into a percentage yet, right? So this is just an incredibly difficult game. It's a lot of fun. You know, if you want to play it, you could probably play it, not know anything about baseball, and you might get close. You never know. It could be dumb luck. It could be better if you don't know anything about baseball and you play this game. I tend to think the opposite because I'm a baseball writer, I'm a data scientist, and so I tend to think that if somebody really put together, you know, a strong analytical, they put together a plan, it could be a little closer to like maybe 1%. So that's what I'm going to be talking to you about today. I'm going to be talking to you about my attempt to beat the streak. Yeah, go ahead. I don't mind questions being asked in the middle. That's totally fine.
In that calculation, I think they're assuming though that like nobody would do a double down, right?
I think you're right. Yeah, I'll have to go back and read it, and I think they even mentioned somewhere in there if someone did do a double down.
Right. How that would change.
It makes it way smaller, your odds, because if you're compounding that every day, trying to pick 2 every day, it becomes even more difficult. So I'm sure there's a whole, you could do like a whole mathematical study on whether doubling down is advantageous or not. I don't know, I'm not going to get into that, but you're right. That's not assuming a double down.
Right.
Okay, so that leads us to FanGraphs, the site that I write for. And it's a great website. I encourage you to go there. If you don't like baseball, again, you can do a lot of fun things with data. That's what I do every single week. I try to come up with a new idea of what I'm going to write. You know, it's exhausting, but I like to do it. So here are the steps that I found myself in when I was trying to work through this. First, do I really want to do this? And I say that, you know, a little bit trying to be funny, but also if you're writing for a baseball website that a lot of people read, it gets high traffic, it's a high traffic website, professional baseball players are reading it, professional managers are reading it, general managers of teams are reading this website and your work on this website. I mean, it's a big deal amongst the baseball community. Baseball nerds, it's a small community, right? But it's still a community, and a lot of people go there for it. So my name is attached to this game that is like impossible to win, and somehow I'm still trying to win it. So, do you really want to do that? I don't know. I already have a job, so this is just my hobby, so that's kind of fine. But if I was like trying to become a baseball analyst for a team, which I did one time try to do, I don't think I would do this and post my work at least. Okay, second, once you decide that you want to do this crazy thing, you need to find data to use, right? And so I'm going to show you sort of my process for doing that and my process for using data to try at least to take a first stab at this. And so I'm going to take a quick look at Baseball Savant. Baseball Savant is a website that basically hosts all the data from StatCast. StatCast, if you're unfamiliar with it, is a system set up in every single Major League Baseball stadium. There's, I don't know the technology behind it. I just know there's a lot of cameras, a lot of sensors set up to measure basically everything that you could ever want to measure. Like it can measure how fast somebody spits sunflower seeds out of their mouth, right? It's measuring everything. And so, as you can see here from this list of columns in a Python data set and a data frame, there's a tremendous amount of things that are being measured on every single pitch that's thrown. This is pitch level data. Okay, so that means every single one of these features is coming from one single pitch being thrown by the pitcher. And so, in order to do this, you need to determine, okay, what am I going to use that feature selection? All right, so how about a raise of hands? Maybe you like baseball, maybe you don't, but just think about it. Somebody throwing a baseball and somebody trying to hit a baseball, what kinds of things do you think that you would like to include in a model to determine if the hitter will get a hit? Any ideas? Yeah?
Pitch type.
Pitch type, perfect, yes, absolutely. Yep.
Maybe if the batter or pitcher is left-handed or right-handed?
Yes, very good, very good. That's a real serious feature if you have a right-handed pitcher, right, and you have a right-handed batter standing here, right, right-handed pitcher, right-handed batter. The pitcher is using that to his advantage by throwing pitches like a slider, like a pitch type, that's going to come into this pitcher, come into the batter, and at the very last second cut away from that batter, right? So when they go to swing, it's coming, it's coming, it's coming, but because they're a right-handed pitcher and they're able to put a certain spin on that ball, that slider is going to just whoop, go the other way. So that's a really good one. Both of those things are really good. Any others? Yeah?
Features that are related to the motion of batter and pitcher.
Pitchers that are related to the motion of what?
Like the throwing speed and bat speed.
Yes, yep, very good. Bat speed is an incredible one, but pitch speed is also an incredible, important one. Faster pitches are harder to hit. Any other ones? Mm-hmm. Inning, yes, I would say so. It would definitely be something that I would throw into a model for sure. I mean, a hitter hitting a pitch in the top of the first might be a lot different than a hitter hitting a pitch in the top of the eighth, maybe when the game is tied. So yeah, that's.
Let me refine that just a little bit.
Sure.
The pitch count.
Yes, the pitch count. It's 3-2 count.
No. How many pitches has this pitcher thrown in this game?
Mm-hmm. Yeah.
Because they've been changing pitchers out.
Exactly. He's probably tired. The ball's probably not moving as fast as it used to. The batters have identified all of his tricks at this point, so that's a great one. Yeah. One last one.
Did you use like the previous history of strikes for the batter?
Yes, absolutely. So how often does that batter swing and miss, right?
Yeah.
If he swings and misses 40% of the time, I'm probably not going to want to pick that batter to get a hit, right? So there's definitely 40% might be high. Let's double check on that.
Because that'd be a 60% hit rate, wouldn't it?
Well, swing and miss, you can do all kinds of different things, but a swing and miss is just one specific thing, right?
Oh,
So
okay.
you could not swing and get a called strike.
Right.
So yeah, that's a good point. Let's look. So leading amongst qualified hitters, swinging strike percentage is at 18.8%. So that was way too high. 18.8% is the highest. That belongs to a Washington National. Luke Boyd. You can go see him if you want to sit in traffic for a little while. All right, so let's get back to feature selection. So this is my data frame. There's a ton of stuff here. I'll click over to my model building. Let's zoom in on this so it's a little bit bigger. And this is, I'm importing all my libraries. Obviously, you've seen this before if you've used Python, but this is a key one right here. This allows me to, this is an API connection. Basically, it allows me to download StatCast data directly from the API as opposed to going to Baseball Savant, which is the website, and exporting a CSV every single time you want to change or add a date or whatever. So if you're at all interested in working with this, it's called PyBaseball, Python Baseball, and it basically is just somebody creating an API that you can call, you could call one single day, you could call a whole time period, you could change the parameters and do things that are specific to certain pitchers. So this is a key aspect of this project, and unfortunately, it's broken right now. So, so many of you in here are probably very familiar with this type of thing. You get to go, you get working on somebody else's model, somebody else's API, somebody else's library that they've built, and for whatever reason it's broken, and it was their project, it was their hobby, and they don't have time to fix it. You got to wait 2 weeks, right? So there's all kinds of little things like that that can happen in this project. Here I'm just building out some functions that allow me to create some visuals. It's not really important. You can see, like, what you're going to see in this notebook is not, it's not like production level, okay? So if you're like a serious Python coder, be gentle with me because I'm doing this like from, 7 p.m. to 9 p.m. With all kinds of other things going on. So it's not as efficient as it probably should be, that's what I'm trying to say. But you can see here what I've most recently done, and just as a demo, I've just called the past couple days, and I did this yesterday, so actually I did this Tuesday. So it's not going to be updated for yesterday and obviously today's games. But these are all the columns. This is what was in a screenshot, and we can look at just one row of data here. We have pitch type.
Here.
Question?
No.
Oh, okay. We have a pitch type, forcing fastball, that's FF. We have the game date, we have release speed, release position. Let's see, so somebody said pitch type, that was a good one. What were some of the others? We said count.
Left-handed and right-handed?
Left-handed and right-handed, that's there. Key throws, and stand is for the batter. So this is a righty-righty matchup. We have the home team. This is an important one because in baseball, every single stadium is slightly different. Some baseball stadiums, you can hit a home run at a certain to right field at a shorter distance than other stadiums where that might be a farther distance away, that home run wall, right? So it depends, like the stadium that you're playing in, big time. In addition to that, like for example, Colorado is famous for obviously higher elevation, which means lower. Thank you, air pressure, and so the ball is going to, technically, it should move easier through the air, right? Is that right? And so, in that case, balls are coming flying at all over the place, and they can go farther. But in addition to that, Colorado's field is much, people don't realize this, everybody always thinks it's just about the air pressure. This stadium is actually much larger. The outfield is significantly larger and has more area around it, and that's for balls to just fall into play, right? And so it's not all about hitting a home run. All we're trying to do in this game is just predict a hit, right? So I'm going to start moving a little bit faster. I didn't think I would be taking this long, but I love baseball, and I could talk about this all night long. So here's another one, an interesting one, shift. Okay, this is getting, so I'm moving forward now. This is getting me to my next point. If you're going to create a model and train it on a lot of data, when you deploy that model, you all know this, you have to have the same features in your model, right? So I can't really determine, okay, a shift would be great. Like this very small data set is a really small sample. It's not very telling, right? Because there's like 22 singles with a shift on and 24 singles with no shift. A shift, if you're unfamiliar, is when the fielders in the field will move strategically to get the ball out, right? They can stand anywhere that they want to, and if they know that you hit it this way, like 60% of the time, they're going to move that way to get that ball, right? So a shift on, shift on, shift on, shift off is a really great feature, but tomorrow when Manny Machado goes to the plate, will the shift be on, will the shift be off? I don't know. you can't predict that. So if I want to deploy my model tomorrow morning, let's say at 8 a.m., so I have plenty of time before the game begins, let's say it's an afternoon game, 1 p.m., do I know if the shift is on or not? No, I don't. So I really can't put that in my model. I could predict, okay, Manny Machado is playing the Colorado Rockies, and they shifted on him every single time that they faced him, but do you really want to put that in your model with a degree of certainty that it's actually going to happen? I don't. So that gets us to the next really important point. When we have all of these features, a lot of the ones that people have mentioned, what's the count, what's the pitch type, what's the matchup, what's the weather, what did the player have for dinner before the game, was it a steak, was it something healthy, is he vegan, we don't know. So none of these things that you see here, well I shouldn't say none, a lot of these things we cannot determine ahead of time. So what do? We have training data, we have testing data, we can validate our models, we can build all these models, but what do we do about actual deployment data set? So again, with the shift, you don't know if the team will shift on player A or not. Here's a visual of the shift, just in case anybody is unfamiliar with it. Typically, the green and red, that's third base and shortstop, right? But you can see that second baseman is much closer to the shortstop than he typically would be. It would be, playing straight up, would be, the second baseman would be here, right? And baseball has gotten so advanced in the analytics that sometimes what they'll do is they'll shift this shortstop over to play right here in the outfield. Sometimes they'll have 5 outfielders. Sometimes they'll just put they'll bring in an outfielder to play the infield. So it really is unpredictable if you're trying to think of what's going to happen tomorrow. It's not unpredictable when you think of the whole season, but it is unpredictable when you think what's going to happen tomorrow. Yeah.
Is there, in general, is there like a percentage of how many hitters are pull hitters, how many hit away? Is it balanced, and then there's people you can't tell, they can do either one? Maybe?
Absolutely. Yeah, good question. Absolutely. I mean, we could even look at that right here. FanGraphs will tell us. So if we look at batted ball data, right, we can look at pull percentage.
The other one's opposite.
Dalton Varsho, opposite. And then center is just sort of like right up the middle, right? I mean, that's kind of rare to have a high percentage of that. A pull hitter is much more common nowadays. 54.5% of the time, Dalton Varsho, you can count on the fact that he's getting shifted on for sure. Yeah.
They play the. Do they ever play with 5 outfielders?
Yes, they have. Yeah.
Because I remember they played with 5 infielders. I remember like in the bottom of the 9th inning with the winning run on third base, they played with 5 infielders usually.
Yes. Yeah, and that's part of the problem is it can be so situational that predicting it the morning before the game can be very difficult, right? Yeah.
I have a question. Let me start by saying that I don't know anything about baseball.
Okay,
I was not born here, so I don't know anything about baseball. But I know a little bit about machine learning. So I wonder, you're applying your logic and your knowledge of baseball to choose the features, right? And if that worked, someone else would have won the $5 million, right? So I wonder, why are you not just utilizing the power of the data itself? You have a lot of data, you know when people hit or not, right? Why not select the features automatically? Maybe it turns out that there's something that you were not expecting, and I don't know, like how many people were in the audience or whatever, like some weird feature that will be better at predicting the hits than the logic that you're applying, right?
Yeah, excellent, thought process, and that's really what the data science process is all about, right? I mean, I'm using my knowledge of baseball, but I'm also using some feature engineering, and not feature engineering, feature selection that I just wanted to see what would stick. Yeah, so for sure, that's like a really important part. Yeah.
Do you record just any of your features you're using on fire by chance? I would imagine that like a Nico Hernandez game is going to be different than another just as far as they're calling balls and strikes and what that might compel certain hitters to swing on. Okay.
Yeah, right there. Yeah, good idea. I mean, again, this is the complicated part of the machine learning process. I don't know anywhere that I have it available every morning that I'll know where the umpires will be the next day. See what I'm saying?
Yeah.
So I have no clue where, that doesn't get posted online. Like, nobody cares about that, right? Like, I would love to put that in my model, but you don't even know who the pitcher of the team is going to be sometimes until like an hour before the game. So there's a lot of complicated factors in this process, but that's a really great point that you just made. Okay, I'm going to start moving a little bit faster here. So I did all that. I did all this feature selection. I've written about it. You've probably seen this image before. I've looked at what's important, what's not important. I iterated. I went through this whole process, right? A lot of the things that you all mentioned are up there. Pitch type, I just turned into categoricals. Was it a fastball? Was it not a fastball, right? Could probably bin those together and put them together, maybe, I don't know. But each pitch nowadays has significantly different characteristics about it, so you probably wouldn't want to bin them together. Standing left and right for the batter, throwing left and right for the pitcher. Okay, all of these things, and this is probably the closest that I got so far. Even with this though, this is really difficult. All of these features can be really difficult to determine the following day. Like, yes, Lucas Giolito is a pitcher for the Chicago White Sox. He has a changeup, really good changeup. Not this year. I don't know why. Could probably figure it out. But I know he has a changeup, and I have data that says he throws that pitch a certain percentage of time. For example, here's Jacob deGrom. This pitcher, one of the best pitchers maybe ever. And we can look at his pitching percentages. He throws a slider 40% of the time. Throws a four-seam fastball 46% of the time, right? So we can pick up on these things. We can see, okay, yes, pitcher, deGrom, fastball 46% of the time. You're probably going to see it in the game, right? And so this was some research it's not really research. These are like scouts. And basically, I'm going to read this out loud because this is probably the breakthrough that I had when it comes to building this model. It says there's a lot of ideas to consider when a manager is setting a lineup for the game that night. Not very different from a person trying to pick somebody who's going to get a hit from deep the street, right? The most important concepts to consider in this situation are the plane of the pitcher's fastball to the plate. So when a pitcher throws the ball, the plane that we're talking about, if he's a right-hander and he throws over the top like this, the plane, the gravity is going to take effect on that ball, and that's the plane, right, as it comes into the batter's box. So that's what we're talking about when we talk about the plane of the pitcher's fastball to the plate, and the plane of the hitter's swing through the zone. So if that is coming in real steep and you got a guy who's very level with his swing, that's not a very good matchup, right? But you have some hitters nowadays who have this uppercut swing, right? And if they're meeting that bat path up on this upswing where the pitch is coming, then you have something that you're working with there, right? And we can figure that out with our data. We can determine those things. Imagine the hitter being a power hitter who hits the ball in the air, has the bat speed to get away with it, and having a bit of a longer path to the zone. Think Ronald Acuna, he's one of the best players in the league right now. Designs to increase bat speed and scoop the ball into the air. The ball is steep, coming down from the pitcher's hand, much steeper than average, and the hitter's swing path is also steep, coming up at the ball, also much steeper than average. You can see why this is a good matchup. All else being equal, his swing path is on plane with the pitcher for a longer time, giving him margin for error. So this is a bit of a breakthrough that I have. This is a visual that shows both of these things. You can see here this is from the catcher's perspective and the pitcher releasing their pitches. This is the release point, right? And this is measured in our data every single row. We get to see the release point, the X and the Y and the Z. And then we also have on every single pitch, in our pitch level data, we have really it's an exit, it's a launch angle. So the ball has to be met with the bat, and it's the angle in which the ball comes off of the bat, right? But that can be translated back a little bit and assumed to be a swing path as well. Okay, because if you're hacking down at a ball that's coming in on a steep plane, right, that's not going to be a hit. Unless you're really fast and you just hit it into the ground. So these are the things that have kind of come through in my model. Here's an example of what training data can look like for this. We have a pitch type, we have a release point, we have the batter's matchup, we have plate X and Z. That's where the pitch, that's where the pitch lands in the zone. If it's out of the zone or if it's in the zone and where in the zone it is. Launch angle, spin rate of the ball, the park factor. This is a calculation that allows it. Basically, you assume 100 is average, and anything below that makes it more of a pitcher's park. Anything above it makes it more of a hitter's park. That's what I was talking about with the different ballparks. Colorado would be like 103, 104. And so the question then becomes, how do you get to that training data, right? How do you create that? Because you don't really know what's going to happen. And so I went through a few iterations. First, I simulated it. I basically just said, I looped through every pitcher pitching that day, and I said, this is what they usually pitch. Let's simulate this on the percentage in which they throw their fastball, and let's just create synthetic simulated data and match that back up with the simulated hitter data. If we know a hitter usually is on the swing path this often, we can also simulate that, compare them together, and there you go. You have your deployment data. The only problem with that is you have a tremendous amount of, like what's actually going to happen, right? You just simulated a whole crap ton of data. Well, what's actually going to happen? And sometimes you get lucky. I mean, that's what I was doing in this post. I said in this one, Michael Brantley was likely to hit on opening day if this guy, Chris Bassett, pitcher for the Mets now, used to be the Oakland A's, threw a changeup low in the zone. I'm sorry, I said that if you threw a slider low in the zone right here, Michael Brantley was going to hit it because of Michael Brantley's swing path. Here's what happened. Boom, baby! One hit closer to $5.6 million. I got that one right. I got the next day wrong, so I was back down to 0. My streak was only 1. So that's the idea. The idea is that if I can simulate this, and I can simulate the batter's swing path to the ball, I might be able to make some good picks. Okay, so I'm going to fast forward a little bit. I used to simulate data. I don't do that anymore. I just take averages. So I just take the average now because I don't want to just throw in. Also, one thing I write in the article, I said if he throws a slider at that area of the zone, he's going to hit it, no doubt. He threw a changeup and he hit it. So the pitch type wasn't right. Maybe it was a changeup that looked like a slider. I don't know. Maybe I just got lucky. Probably I just got lucky. So instead of simulating data, I just took the average, right? I just said, well, this pitcher throws a fastball here most of the time, and here's the velocity. Here's the average velocity over the season. Here's the average release point. Here's the average swing path of the hitter. So if he's here, right? In general, he's going to have an average swing somewhere in this area. And that's what I did. That was my next iteration. So iteration 2 is just averaged out pitch level data. Iteration 3 is marking current hitter standing against current pitcher standing. So what that means is, just like you said, I believe it was, well, some hitters swing and miss a whole lot more often than others, right? So I basically just took season-wide data for the day before, and I said, well, this hitter on this season so far has been swinging and missing a lot. In my model, I'm determining, is he likely to get a hit, yes or no, and that's a feature in the model. He's swinging and missing a whole lot, I'm not going to pick him.
But are you doing, like when you do this analysis, you mentioned averages, are you taking the average, or are you treating this as like time series or longitudinal data?
Just taking the average. If a pitcher throws a fastball at 92, 93, 94, I'm just going to call it 93.
Okay.
Yeah. Yeah.
Oh, that was my questions on the similar vein. Curious if you were taking any type of moving average to.
I'm going to show you that in a second. Good point. I'm going to show some code and then I'm going to show my process for choosing. Yeah.
So how do we handle outliers? Are there any outliers?
That's a good one. For this secondary model right here, so I'm ensembling two models together. I'm ensembling averaged out matchup data, right, and I'm adding that to, I'm ensembling that with this secondary model. The way that I take care of outliers, I'll show you in the code. But I also, when I do this model, I take minimum plate appearances. So like, you know, if you have that guy who's only been to the plate 5 times in the past 2 days, he's not entering my model at all. Like I won't even pick him. So he could be an outlier because he's suddenly batting. He could be an outlier because like he hit the ball a crap ton harder than anybody else all season. But like it was his first game and he's rested and he's young and he's juiced, and so that's an outlier, right? So I eliminate that in this process. Yeah, good question. Okay, let's move a little bit quicker here. This is also just going to show you like the average, right? This is a slider, so I can take. You can tell that this is a right-handed batter. The batter is standing right here from the catcher's perspective. He's trying to swing at all these pitches that are from this perspective down here, right? So if I take the average of that, I can assume, and really what I mean by the average is like the centroid of this cluster. So I can assume that he's throwing that pitch down and away to a right-handed hitter. Okay, let me move over to the code. Well, I already talked about the issues with simulated data. It was very clunky. It ended up being very time-consuming because you're creating a tremendous amount of data, and it just really wasn't working for the process. This is a screenshot of the code, but I'm going to move over to my notebook to show you when I average out pitch level data, and then the model that this is averaged out and then current standing of the hitter. Okay, so I'm going to show you the process. First, I have to web scrape each day for starting pitchers. I'm going to pass deployment data through model 1, through model 2, ensemble it together, and then I'm going to use some common sense to see if the pitch, the selection even matters. So let's go to this model here. This notebook here, I should say. It's pretty hardy, and I really only have like a couple minutes left, so I'm going to get through it quickly. So I'll go through the important parts here. This is a web scrape that allows me to go to this website every single day and snag the name of the starting pitcher. This is complicated because sometimes if I'm making these picks in the morning before I go to my real day job, this takes a long time to do, and a lot of times the manager hasn't decided who's pitching yet. So you're going to scrape something that's going to be a null value. You have to either eliminate them from your model, or you have to go to FanGraphs and you have to look at who is, somebody is basically saying this is who we think is going to pitch, copy and paste their name, pop it in, right? And that's what I've done, right? I already did that and I deleted that cell, so I can't show you. But typically when I see this, 30, 30, 30, that's where I want it to be. That means there's 30 games, there's 30, it's not games, right? Actually it is games. It's 30 stadiums across the league that day, right? 30 stadiums. Each one needs a pitcher to be in the list. I need each stadium to have a pitcher in it. Okay, and then this is the model that I'm using. I'm basically just taking all of these things in their current standing. This is, unfortunately, it has to be a manual process of the CSV download because I don't have a database that I can connect to yet. I'm working on that. But this is just a download of what you saw in that spreadsheet on FanGraphs. And I'm pulling all of these current standing metrics. I'm passing them in through my model. I'm doing some feature engineering here. I'm making sure that I'm matching it up against a categorical binary target of a hit or not a hit, making predictions, and I'm checking those predictions. And so this was for last night's games. I ran this for a subset of data to predict last night's games. So, you know, you said something about rolling averages. I can look up these things, right? So here's Austin Riley. My model, this first model said that Austin Riley was going to be the best guy to get a hit. He has an 85% hit probability by my model, right? So I can use common sense and I can look at Austin Riley. Austin Riley in the past few games, his average, if we just look at his batting average, it's really going down. But he has sort of had a little bit of a spike, but he's still very below average. His batting average is very below average, right? A really important metric in this decision is hard hit rate as well. So how hard are you hitting the ball? If you hit the ball hard, it's going to go through the infield a lot quicker and the defense is going to be able to get to it. His hard hit rate is also really, really low, and it's really below average. So I don't like that pick. This goes to show you the process. Like, it's not just about creating a model and making a prediction. It's about using what you know and what you have available to you to make a better prediction.
What's the scale of that? How many at-bats?
It's a 15-game rolling average.
So that could be 60 at-bats for somebody?
Yeah. Yeah.
Have you tracked, picks that, in this case, Scott's 85% hit probability? Have you kept track of instances where you're getting a high hit probability when you've selected someone else for that streak and seen, just sort of track, okay, is the model sort of outperforming my domain knowledge pick?
Yeah, for sure. I mean, I would make picks and then look it up against who the app actually of the game will suggest picks. So they have their own internal model. But you also have to think like, well, why would they build an internal model and help people win $5.6 million? That doesn't make any sense. So I don't know how much I trust it. But I would compare my picks with their picks and see which one would make sense. And I didn't like. It would be interesting to compare my picks to like just what I thought would be good off the top of my head, kind of a thing, right? So that's model 1. Model 2 is a little bit more intricate. It requires a connection to that API. It requires you to loop through the daily pictures that you have scraped. And this is a really clunky for loop, so if you're an expert coder, maybe you can turn this into a much more efficient process. But basically, I'm scraping every picture. I'm pulling all of their metrics for a certain time period, and I'm averaging it all together. I'm also doing this thing where I'm calculating vertical approach angle, which is very similar to what we talked about when the pitch comes in and how it approaches the plate. That's a secondary metric that I've added there. Next, this is all just pretty straightforward data compilation type of things. I'm just sort of combining them up, making sure the IDs are the right matched to the right player, passing it through my secondary model, and I'm really fast forwarding here. I could talk about this all night, but I am combining the models by a multiplier. So this is really my prediction, but I'm not just using that and sorting it by that, because I want to look at all 3 of my model scores. This model is, it's just looking at how this player has done in the past like 10 days. This model is looking at how this player has done and what his swing is like when it compares to the pitcher and the pitches that he throws and the angles that he brings his ball into the plate at. And that is really combined into this prediction. Okay, so let's just check it out. Jeremy Pena was my pick for last night. Let's see if he got a hit. I've already looked, just to let you know. Here's Jeremy Pena. Also, one last thing before I show you if you got a hit or not. Actually, I think you can see it there. Yeah, you can. I wanted to just see, okay, Jeremy Pena is my pick. How has he done? He's gotten 15 hits in the past, 17 days. 15 hits isn't bad. He's not really walking, which is actually a good thing. You don't want to pick a player who likes to walk. He's striking out, not too bad, 17% of the time. His BABIP is 250. BABIP is batting average on balls in play, but his batting average is 238, which is it's not great. But I'm just going to trust my model because it's looking at much more than batting average, right? And so here is the box score from last night's game. Jeremy Pena batted first. He got 1 hit. My model predicted correctly last night. 1 step closer to $5.6 million, but I'll have to wait until next season to actually win. This is where you can applaud me. And so another interesting thing to note is Jeremy Pena batted first. Jeremy Pena got 5 plate appearances as opposed to Kyle Tucker, who batted third and got 4 plate appearances. He got to bat less times. Also, you'll notice Jose Altuve is Jeremy Pena's teammate. Kyle Tucker is Jeremy Pena's teammate. I predicted 3 Astros to get a hit. There was something about this matchup that my models combined liked, and they were going up against a pitcher named Zach Gallen. He's pretty good. I don't understand it. It would take me probably the rest of the day to try and figure out why my model picked what it picked. And now, with that, you can see why I am still not a millionaire. Just to end on a note about what's next. I talked about the drawbacks. I've seen some really interesting things and talked to some people that have been playing this game along with me that say, stop, you're really never going to do it, it's impossible. And it kind of is impossible, to be honest. But somebody had a really interesting idea. If you can simulate each game every night and determine how many people have to play the game in order to win, you might be able to put together a team and use a spread of picks to get a little bit closer to meeting that percentage, right? So if you could simulate and every single day figure out every day of the season how many people need to play and all come together, you might be able to build a team that can beat the game. That's an interesting strategy. It might be something that happens in the future. That's all I have for you. Thank you so much for listening to me ramble on about baseball. I'm happy to talk more about it, as you can see, but I really appreciate the opportunity to come and speak to you, and I'm happy to answer any last questions that you have.
On slide 17.
I'm sorry?
On slide 17.
Slide 17. Yeah.
Oh, sorry, maybe not that one. It was the one where you had the model probability, like when you were talking about this player recently.
Mm-hmm.
Yes. Why is the model 1 prob greater than 1?
It's because it's a multiplier of 2 scores. So it's really no longer a probability, it's really just a model score. So what I'm doing here is I'm multiplying out the probability of 2 different hits, but I'm also weighting it by the amount of predictions that my model made.
Oh,
so for some players, like my model has predicted 8 hits because of the way I've structured my data. For other players, it's only predicted 2 hits.
So it's like the weighted average?
Exactly. My model is it's just weighted because my model is predicting more basically plate appearances for some players than others.
Okay.
Yeah. So I just turned that into a model score and sort on that. Yeah.
Do you have any thoughts on how you would overcome, like in the new season, the cold start problem where you don't have recent data to go off of?
Yeah, that's a great question. I used the previous season.
Because
that is challenging because, like, okay, we know Jacob DeGrom's going to throw a really fast ball in the top of the zone, right? But other pitchers over the spring training have tweaked a whole bunch of different things. They could come back a completely different pitcher. So you really, at the very start of the season, it might be better just to use like common knowledge and your best bet, because you're right, it is like a cold start problem. I mean, you can also just limit it to like more experienced players who you know have sort of hit that, who've leveled out and are probably not tweaking things, and you can rely on their career averages a little bit better. But that's a good question.
Yeah, so actually not a question. So there are certain things that I would like to share along this line. So I used to work on fantasy Premier Leagues.
Oh yeah?
Yeah, so that time I kind of, so the point that you made about grouping people. So what I did was I grouped people on popular choice and differential choice. Where I say popular choice means they always pick this player because he's popular among the crowd. Differential choice means sometimes he hits very well, sometimes he doesn't. And sometimes he's playing in his native country or native state. He probably knows the space very well, so he would definitely do very well.
Mm-hmm.
Or maybe he's known, or he has been there sometimes, or he has been in the home team, or he has been a part of the what do you call university team, so he knows that area very well.
Mm.
So there are two popularities. So there is one popularity way of choosing players, another is a differential choice. So I kind of looked at it and see that if my model understood the features separately, can those features somehow aggregately match the same player up in the hierarchy or not?
That's interesting. Yeah.
So
in your way, you're almost ensembling two models, but really you're selecting variables from each. Interesting.
Yes.
Yeah. I like that.
And another thing that if you want to try out with various models, I actually built a library called Magic Loops.
Magic Loops?
Loops.
Loops, okay.
Yeah, so it's a GitHub publicly available. then I have put all my models over there.
Okay.
So
I'll check it out.
It can have all the features, and you can run like Magic Loops GitHub. Yeah, you have to put GitHub because that's.
Are you sure it's not this Magic Loop product here?
You have to type
GitHub, I got you. Cool.
Yeah, flash.
Very nice. Okay, I'll check that out. Thanks for the tip. Yeah.
Did you say the best you've done? Did you say how many you picked?
Oh, you don't want to hear it.
I do actually.
I think the best I've done is 14, but like I've only, to be completely transparent and honest, I've already, like, you've heard me complaining about how difficult this is. This process I went like 20 days maybe, and it was just too difficult. Like, not only does it take a long time to run, stuff is always freaking broken, and then I got to go to work. You know what I mean? So it's just like hobby work that takes too long every single day is the thing that I've realized. And so honestly, like at this point, there was a point where I was like, I don't want to share my code with you because like I could win $5.6 million, right? People were always asking me, I write on this website. And now I'm like, sure, you can have it because I'm done with this crap. Like, I'm not done with playing the game, but I've realized that it's not scalable. And that's what it needs to be. It needs to be scalable in order to be utilized, which is probably what you all have heard before, or anybody gets asked in an interview, when you talk about these projects, well, is it scalable? My answer would be no, it's not. I have to sit there for like hours trying to do it. So that, in my mind, I'm not giving up. It just, that's what needs to happen next. It needs to be scalable. Yeah.
You mentioned that there was some conversations on some place. Do you know if the folks that are doing the best, if they're just picking, or if they have any models or anything?
I would say very little of them are. I mean, I don't know. I don't know. Like,
you think they've done similar work? Is that
the people who have made the longest streaks?
Yeah.
I don't know. I really don't know the answer.
Okay.
Like on that podcast, they bring the people on sometimes, and like they've never talked about building like machine learning models.
Okay.
It's usually just fans who I think have just gotten lucky. And honestly, if you look at their picks, like sometimes they've just caught a player's hot streak. And they've just ridden it. So they pick the same player over and over and over for 12, games, and then they dropped them because whatever, and then so it is really interesting to see like the picks that have been made. Not to say that they're not, obviously they made it way farther than me, but I don't think many people are using machine learning.
Yeah, for comparison, like, so on Investopedia, they have a competition to see who can invest money and get the largest return. Some guy has like 383 trillion % return, doing something that nobody in their right mind would do, but they got lucky just picking something randomly. But I had a question about, so when, say for instance, Las Vegas, when they set a line on a baseball game, because I was looking at like lines this year, I'm like, how in the heck did they come up with something like that? Do you know, or do you think they just model the game based on who's expected to start and these kinds of things about how they are expected to be successful against the pitcher, and come up with, okay, 6'5" in general, something like that? Is that what they do, you think?
Nowadays, yes. Just a few years ago, no. Because you can see these Bet MGM, FanDuel, all those places that set line, even if it's not like a casino in Vegas that sets the line, they're hiring data scientists like crazy. So no doubt they're using some pretty intricate machine learning to set the line. Yeah. I mean, I don't know that for sure, but like I'm pretty sure. So yeah.
I was wondering, some of the features that you're using and the values that you're using, these are numerical features, and it's not very clear to me how is this data being captured and how accurate it is, right? Because you're talking about the angle, for example, and a variation of like 1 dB might have a big difference there, right? So
100%.
Sometimes when people create these kind of models, for example, for the stock market, right? They have accurate data, the number of stock, but in your case it's not accurate, right? So are you accounting for that? Like, do you know how precise the values are, and can you account for it somehow?
Yeah, it's a great question, and you're right. I mean, it's going to be riddled with errors. The common phrase in fantasy baseball is regression to the mean. Regression to the mean. The player has an incredibly successful season, and their past 4 seasons were not that way. The following season, they are going to regress to the mean. You can count on it like gravity, right? So that's kind of been my theory with the averages. Is like for a lot of these things, in my mind, it's sort of regression to the mean, and if it's a really large sample, over time it will. But you're right, when you're thinking of it on a micro level, one swing of the bat at a certain angle can have a gigantic impact on the way the ball is hit, and that's what makes baseball so much fun. So, you know, I don't know the answer to that.
And how do they, do you know how do they collect that data? Is just like by analyzing the images, the camera images? Do they have sensors? Or?
It's all sensors. It's sensors, but it's high. I mean, I don't even know. In every stadium, they have something called Hawkeye and StatCat. It's called Hawkeye, and it's a system in the stadium that's capturing all of these.
Which is introducing already there or something.
One thing I was thinking about, because you mentioned that like stadium size and elevation, things like these can be very important for, you know, this analysis. If you wanted to simplify it, couldn't you like take that into account and do some transformations on some of the other variables? What I'm trying to say is like, say like the speed of the ball. Couldn't you modify that by some of the other variables and transform them and like reduce the number of features that you're trying to select from? Does that make sense?
Are you explaining sort of like a principal component analysis where you're sort of?
I'm thinking more like standardizing it, because like the same pitcher who throws the same speed, but like they're in two different stadiums and two different elevations.
Yeah.
Like that's the scenario that
I actually, I had an interview with the Mets, and actually before you can interview, I didn't have an interview, I had like a coding challenge. That's what they were trying to get us to do, is to normalize every single stadium.
Yes, exactly.
And it's like Major League Baseball teams are trying to do that, so I'm sure it's done, but to do that on every single variable, every single day across all these different stadiums, it would definitely be a challenge, for sure.
Okay.
But it's an excellent point. Your thinking is totally in line with what Major League Baseball teams are trying to do.
Right.
Yeah, because like the sensor in the stadium could be a little bit off that day, right? And so if it's collecting data, I mean, it's collecting a slightly different measurement, than another stadium before it's fixed, and that's going to introduce error into your model. So some of these things you just can't fix. Yeah.
You said they track the plane of the ball, and they also track the rotation of the ball, and the axis of the rotation, I presume, things like that. I need kind of like, if it's not exact, But I had sort of not an individual question, but like they make a big deal out of a team winning 100 games in baseball. And when somebody just eyeballs it, you see like 100 wins, 62 losses. You'd say, oh, that's the same as 10-6 in football, but it really isn't, because you look at how frequently a team can win 100. It's more equivalent to like a 13-3 or even a 14-2 season for football. And why do you suppose it is that they don't win as high a percentage? Like, if you were to project out even I think NBA, the highest record was something like maybe 72-10. So if you basically doubled that, because I think they play an 82-game schedule, it's pretty close. So 140 wins or something, that's nowhere, that's way out of the realm. Is it just because the season's so long and the chance of people getting injured or whatever, there's kind of fatigue or whatever?
For sure, all of those things, and it can come down to something as simple and stupid as a ball being hit right to the shortstop, and at the very last second makes that spin and bounces this way when the shortstop was standing right here. And that's what makes baseball such a fun and interesting game, is that type of thing happens all the time. And on this website, on the analytics website, FanGraphs, is a lot of people just trying to figure out what's luck, what's not luck, and a lot of really smart people are trying to answer that question all the time.
On that, I just want to say one last thing. There was a game the Texas Rangers beat, I think, the Orioles a few years ago. It was 28 or 30. They scored 28 or 30 runs. And so you would think like, oh God, they had to be hitting grand slam home runs and stuff. And then a lot of the hits were these like bleeders getting on the outfielder, getting into the outfield, and two guys would score and stuff. And it was exactly that. It was stuff where guys misplayed a ball, and so it wasn't cannon shots or anything.
I saw this guy was at bat, he stepped out of the box and he was clutching his chest, and all the trainers came running out. Everybody was so concerned about him, they took him out of the game. Turned out he just had heartburn. You know what I mean? It's hard to hit a fastball when you got heartburn. And with that, I think I'm going to say goodnight, and I don't want to wear out my welcome.
I had one last one.
Okay, one last one.
Related to the sports betting though, because they do prop bets. Have you ever looked at trying to do a prop bet on whether a batter will make a hit that night? And like look to see if you're.
My favorite part about this game is that it's free.
You might make $5 million just doing it.
Maybe, yeah. I don't have the money to like put up for it yet, so. Maybe if I win, I'll take $1 million and I'll flip it back in, but I don't think so. Yeah.
Awesome. Well, let's give him a round of applause.